maximize the window, and I need to share the window. All right. So here we go. So here's Aaliyah's problem. Like I said, fantastic problem. Directions are simple. Solve. 3y over 3y plus 9 plus 2y minus 14 over 2y plus 6 equals 4y minus 1 over y plus 3. All right? Now, first thing I do, all right, is I factor out all the denominators. I just factor them real quick. All right? I know I need to do that, so I'm going to factor them real fast. So I just rewrite it. 3y over 3 times y plus 3 plus 2y minus 14 over 2 times y plus 3 equals 4y minus 1 over y plus 3. Now, the next thing I will do is I'll look at my denominators and I'll say, okay, I know I'm solving. I know I'm going to get an answer for y. I want to make sure it's a good answer. So I look at every denominator. I will set them equal to 0. And I will find out what answers am I not allowed to have. All right? Remember, this is equivalent to asking the question, find the domain for this problem. So, notice they all have a y plus 3. And remember, when we're finding domain, we take the factor that contains the variable and we set it equal to 0. That's why I don't have to worry about the 3 and I don't have to worry about the 2. I just take the factor that contains the variable, and I found that y is not allowed to equal -3. So if I do all this work and I come down to a solution of y equals 3, I know that's not valid. Okay? Are there any questions there? All right. So, one more thing. I'm going to rewrite the problem. Does anybody see anything else I can do with this problem before I get into the nitty-gritty of it? Does anybody see anything? I mean, I see it. Would you like a hint? You want a hint? What can I do with those two numbers? I can simplify. Remember, the numerator is everything's being multiplied. Denominator, you factored it, so it's being multiplied. So that 3 over 3 I can reduce. Does anybody see anything else? What do you see, B? Yeah, very good. This 2y minus 14, I can factor that. To say 2 times y minus 7, and I can reduce the 2's. So there was a lot of upfront work that I can do to try to make my life a little bit easier. If you missed it, don't worry. It's going to come out at the end the same exact answer. It's just you're going to have maybe a little bit larger numbers, but that's not a big deal. You know how to deal with that stuff. So let me go ahead and simplify this. So the 3's reduce. The 2's reduce. So finally, and I'll leave everything in parentheses. I like that. It makes me feel good. So finally I get to this. So step one, what's my LCD? Because remember, though I don't like fractions, I learned how to get rid of them. How do I do that? I multiply every single term by the LCD to eliminate all fractions, or all denominators more specifically. So what's my LCD here? Perfect. In stereo. Thank you, Jada. Thank you, Ramzia. So I'm going to multiply every single term by y plus 3. So I'm going to write it out nice and neat. In fact, I'm going to use a bracket too. Okay. Now from here, I'm going to use my highlighter first. And I cannot stress this enough. The whole reason why you chose y plus 3 as an LCD is so when you multiply every single term in the equation by y plus 3, you can reduce them. And if you notice, in every single term, that y plus 3 in the denominator will reduce because y plus 3 in the numerator over y plus 3 in the denominator, regardless of which way you look at it, it simplifies down into 1. Does that make sense, everybody? So what I'm going to do here is I'm going to go ahead and scratch out the y plus 3's in every single term because I know they simplify. And then, what's ever left over, whatever's not highlighted nor scratched, I rewrite it exactly the way it looks. So I get y plus y minus 7 equals 4y minus 1. From here, I see parentheses, so I'll distribute. But if you notice, they're both positive in front of the parentheses, so nothing changes. So I could just remove them. I look on the left-hand side and group any like terms that I can. 2y minus 7 equals. I look on the right-hand side and I group any like terms. Well, there's nothing I can group. Now I will get my variable terms on one side, constant terms on the other, because this problem is linear. All right, so I will subtract 2y from both sides. I like that. I think it's a good move. 4 minus 2 is 2y. Now I will add 1 to get the constant term on the opposite side. That's going to give me negative 6 on the left side. On the right side, I get 2 times y. And then my last step, I divide both sides by 2 to give me a potential solution of y equals negative 3. Now, we know from the very start of the problem, I'm going to scroll all the way back up, that y is not allowed to equal negative 3. Yet, that's what we came up with. So, we put an X and rewrite no solution. So, Aaliyah, if I were to guess, because what you sent me, you got the LCD correct. Your LCD was a little bit different. It was 6 times y plus 3, and that's because you didn't completely factor everything. And that's fine. Like I said, that's fine. Were you checking your solution, though?
Didn't get that far.
Okay.
In the problem because I don't know, I think having my LCD that way and not fully completely confused me.
All right, well, why don't we do this then? Let me ask everybody a question and be honest with me. All the way at the start, this step right here, where I factored the numerators and simplified, how many of you would have done that? Jada, I agree with you. If I was learning this, I probably wouldn't have seen that. And maybe I did a bad job at teaching this. Because see, I mean, I'm not trying to be arrogant here, but I know how to do this pretty well. So maybe I should, Aaliyah, I'm going to do it your way. Is that okay?
Yeah.
All right. Yeah, I'm going to do it your way because I don't think many of us would have seen that. And it's not because we're not smart enough, it's because we don't have enough experience doing this stuff. I mean, you got to understand, I've been teaching this for 10 years. You know, I see things. And sometimes when we're teaching math, that actually hurts our teaching style. Because I need to think more like a student, not like me. So here's what I'm going to do. I'm going to come all the way back to this right here. And the reason I'm coming back to this is because this is something that we definitely have to do. Meaning you definitely have to factor. So why don't you do me a favor? All right? Why don't you just sit back and just watch? No use writing the problem again. You already did it. Just sit back and watch. So, if I approach this problem here and I say, okay, I need to find the LCD, so I factor every single denominator. Like that, you got to do it no matter what. You know, beginner, advanced mathematician, when you take a step back, you have to factor the denominators and find the LCD. I really wish I could turn that off. Now, from here, the LCD is going to be the excuse me. It's going to be the multiplication of unique factors. Okay, it's going to be the product of unique factors. So 3 is unique, 2 is unique, and it doesn't matter which one you pick. So I'm just going to pick this last one here. And the y plus 3 is unique. So 2 times 3 times y plus 3, which is 6 times y plus 3. All right? Now, I'm going to take that, and I'm going to multiply every single term by it. So 6 times y plus 3, and then in brackets, I'm going to put the first term. Now, plus sign, 6, parenthesis y plus 3, and then in brackets, I'll put the second term. Equals, and then the last one, 6 times y plus 3, or the quantity y plus 3, and the last term. All right, Aaliyah, you're going to help me with this, okay? I know I'm putting you on the spot right now, but trust me, it'll be good. So here we go. We know this LCD right here is going to reduce the fraction. Better yet, let me be more specific. We know the LCD is going to reduce the denominator in every single term. Do you agree with that statement?
Yes.
The question becomes how? You with me with that so far?
Mm-hmm.
Here's how we do this. I want you to help me, and you're going to take this one step at a time. The whole reason why you chose 6 times y plus 3 is to reduce denominators. So I want you to look at the 6. I want you to look at the 3. What is 6 divided by 3?
2.
Okay, so what I'm going to do is scratch them out, and I put a 2 right there. Now, the y plus 3 and the y plus 3 also reduce. Do you agree?
Yeah.
All right. So what's ever left over, I'm going to write 2 times 3y. Because remember, this is 2, and these brackets right here still mean multiplication. Do you agree?
Yeah.
All right. Next. Let's look at the 6. Let's look at the 2. What is 6 divided by 2?
3.
Love it. So I scratch them out, and I put a 3. Now the y plus 3 and the y plus 3, they reduce. So I'm going to write everything that's left over. 3, parenthesis, 2y minus 14, equals. Now, on the far right side, I look at the 6, but there's nothing I can reduce it with. Do you agree?
Yeah.
Okay, but the y plus 3's reduce. So now I write it exactly how everything looks. Okay? So in one step, we eliminated all of our denominators using the LCD that you came up with. Now, I see parentheses, I'm going to distribute. 2 times 3 is 6y. 3 times 2y is going to be 6y minus 3 times 14, and please excuse my dear Aunt Sally, because I'm just going to use my calculator for that just to make sure I get it right. But it's 42 equals 6 times 4 is 24y, and then 6 times negative 1 is minus 6. So from here, I group all the like terms on the left side. Well, that's going to be 6y plus 6y, which is 12y, minus 42 equals. I group all the like terms on the right. There's nothing I can do. 24 minus 6. From here, I'm going to get my variable terms together, constant terms on the opposite side. So I'm going to subtract 24y because I want to. That's going to give me negative 12y minus 42 equals negative 6. I will add 42 to both sides. This gets the constant terms on the right and variable terms on the left. Negative 6 plus 42 is going to be positive 36. And Aaliyah, what do you think 36 divided by negative 12 is?
Negative 3.
And we know we are not allowed to have that for an answer. So does that make sense?
Yeah.
See?
I just did it like a much more complicated way because I make everything more complicated.
It's called learning.
Yeah.
I mean, think about something you're really good at, all right? And then think about the first time you ever did it. I mean,
Yeah.
even the first time you may have been pretty good at it, but you figured out a way to be really good at it. Okay? So,
Thank you.
you're very welcome. So, let me zoom out here. The moral of the story is this. And I hope you take this lesson with you in the next math class. Math is not about the numbers. It's about the technique. It's like dancing. All right? And everybody can dance. It's just sometimes it takes more practice. Some of us are naturally really good at math. Newsflash, that wasn't me. All right? When I started off in math, I wonder, I probably can. I'll have to look into this. I'll show you my transcripts. I started off in Math 80. So it's not like I was like this math genius. All right? I started off in Math 80. One thing I did do is I read my book. I had some really good teachers in my academic career that really just pushed me to be better. Some of them were mean, others were very nice, but they kept pushing me, all right? And sometimes, when you talk to people, they say things and it may come off a little abrasive, but just remember that if it's somebody in a position that's trying to teach you something, even though it came off abrasive, our goal is to make sure that you are a better person when you leave. And for me, that's in mathematics. All right? So, understand techniques. Notice, even though I did the problem 2 different ways, the technique did not change. Identify potential problems, right? Find the answers that don't work. Find your LCD. Multiply every single term by that LCD to eliminate fractions. Then determine what type of problem you have after that. If it's linear, follow your steps to solve linear equations. If it's quadratic, follow your steps to solve quadratic equations. Okay? Regardless, though, you have the tools to do this. All right? It's just a matter of practice. A little bit of practice, a little bit of sacrifice. That's it. All right? You got your whole life to work. You got your whole life to go out and party with your friends. You got your whole life to yell at your kids. You got your whole life to hug them. Sacrifice just a little bit of time just to do some math. All right? Because if you can't help yourself, how can you expect to help other people? Good? All right, I'm off my soapbox. Any questions? I love teaching this class. MAT090 and MAT108 are two of my favorite classes to teach. I really like to teach Calc 2 also. I love teaching Calc 2. Calc 2 is a tough course. Who knows, maybe one of you will actually go, you know what, I think I'm going to take some more math. You change your major. Next thing I know, I'm driving over a bridge that you designed. That would be cool. That would be neat. All right. So if there are no further questions, we're going to move into the last material, the last stuff in this class. Wow, I can't believe we have 2 classes left, everybody. Let me show you. Let me show you real fast. I need to go down into here. Come on, mouse, where are you? There you are. Today's the 29th. Our next class is the 4th. Then the class after that is the 6th. And then if you zoom down, after the 6th, that's the 11th. That's the first day of finals. We have 2 classes after today. Not that I'm counting, but I will be sad. So here we go. Chapter 16. The last material of the year. Where's my keyboard? Oh, thank God Artie is sleeping. Artie was a bad boy yesterday. Does anybody want to hear what he did? No, I can't see you because I'm typing, so I need you to unmute yourself and say yes. Nobody wants to hear what he did? Okay.
What do you do?
There you go. So he found, and you know what? It wasn't his fault. It's my fault. It's my wife's fault. It's our fault. He found his bag of treats. And he ate the entire bag. So I am on disgusting number 2 dog duty. Because he has to go to the bathroom all the time. So right now he's sleeping. And you have no idea how happy I am because of that. You know, I'm like following him around the house, like everywhere he goes. Because as soon as he makes that sniffing motion, I'm like, no, outside. And I just pick him up and go. He's like 25 pounds now. He's gained double his weight since we've had him. He's huge. Anyways, so he ate an entire bag of treats. Probably like 40 treats. Some of them had icing on it too. I couldn't believe it. I was like, you gotta be kidding me, dog. It's gonna be sick. As a dog. Hence the phrase. All right, here we go. Chapter 16, Section 1, Compound Inequalities. Okay? Oh, wait, hold on one sec. I gotta... No, I do not, Ramzia. In fact, well, I don't teach it, but that doesn't mean I will never teach it. I just never taught it yet. All right? More on that later. So compound inequalities, all right? So one thing we're going to be talking about here, all right, is the inequality symbol. Does anybody remember our inequality symbols?
Yes.
Okay, what are they?
It's like the greater than.
Perfect.
Lesser than.
Yep. Inequality symbols. So we have x is less than a. X is greater than a. Actually, I'm just going to put greater than. All right. X is less than or equal to. And then x is greater than or equal to. All right. And the thing that we have to remember here, okay, is that these inequalities will actually represent sets of numbers. All right. Let me show you a major difference here. Okay. If I asked you to solve this problem here, x plus 1 equals 5, you would subtract 1 from both sides, and you would say x equals 4. And I would agree 100%. Then I said, okay, why don't you do me a favor? Why don't you graph that on a number line? Well, if I wanted you to graph it on a number line, you would just put a solid dot at 4, and that's it. Okay? Now, if I gave you this example, x plus 1 is less than 5, our method is still the same, okay? The x is raised to the first power, so that means it's linear. So I know I need to get the variable terms on one side, constant terms on the other. All this stuff is still the same. So I still subtract 1 from both sides. And I get x is less than 4. Now, here's the difference. If I asked you to graph this on a number line, you would have to, and this is the way I like to do it. I like using parentheses. So you would put a bold parenthesis, and then you would shade everything to the left. In other words, in the first example, there is one and only one answer, x equals 4. However, in the second example, we have a bunch of answers, as long as they are less than 4. Does that make sense, everybody? All right? And just so, you know, just one more thing, just so we're all on the same page, I will always read my inequalities. So I read from left to right. So, you know, if it's this, I read it left to right. X is greater than 5, okay? I will never, ever read this 5 is less than X. Like, I don't do that. All right? I read it left to right. Another thing I will always do, let's use a different number here. All right? Is if I have the number first and then the variable second, if I read it from left to right, I will switch it around. All right? So that I have the variable front. The thing to remember is that inequality symbol, think of it. Think of the inequality symbol as like where it's pointing to. Since it's pointing to the -1, when I rewrite it, I make sure that it's still pointing to the -1. Okay? All right? Now, today we're going to talk about this thing called compound inequalities. Compound inequalities are nothing more than just two inequalities that we're graphing on the same number line. All right? So, compound inequalities look like this. All right, we can have x plus 3 is less than 8 and x is greater than 1. That's our first example. Notice two inequality symbols, but there's a word in between them. And that word is the word and. All right? The other one we can have, and I'm going to draw a little line here. Let's say x plus 1 is greater than or equal to 2, or negative x plus 10 is less than 7. So the difference is here is the word in between the two inequalities. All right? So the word and means I am looking for values of x that satisfy, and this is the key word, both inequalities. Okay? So when you see that word and, you are looking for the set of x values such that when I substitute them into either inequality, I still get a true statement. So it satisfies both equations. For the or, I am looking for values of x that satisfy 1 or, let me write it like this. At least one inequality. So the or means that I'm looking for values of x that satisfy one inequality Or the other inequality, even both. All right? So the differences between the word and or, and they have to satisfy both. The or only has to satisfy at least one. Okay? So let me show you a picture of the and. So whenever we see this word and, let me say it like this. The word and denotes an intersection of two sets. So, there's a lot of words in there, okay? Really is. All right? First, you're not going to understand any of this if you don't know what sets means in math. So, a set is a collection of objects. All right? A set is a collection of objects. All right? More specifically, it's a collection of objects with a common characteristic. Okay? But for now, I think a set as a collection of objects is pretty good. For example, I can create a set in this room right now. Okay? And that could be the set of students and the set of professors. The set of students, that's all of you. The common characteristic, you all enrolled in the class. The set of teachers is me. I'm the one teaching the course. All right? So a set is a collection of objects. Now, a picture of this is right here. This is called a Venn diagram. Okay? And I'm going to label the first set A and the first set B. So in other words, anything in A is going to have a common characteristic specific to A, and anything in B is going to have a specific characteristic to B. But there is that overlap, and that overlap is right here in the middle. I'm going to color it in green. All right, here's this overlap right here. Okay, and inside that overlap is A intersection B. So I gave you a new symbol. It's the upside down U. That symbol means the intersection. So when we're trying to solve an and problem, we're looking for all the numbers that are contained inside of that green region, because those are going to be the values that satisfy both inequalities. Does that make sense, everyone? Are we all on the same page? All right? So, why don't we do an example then? We'll do the or next. So, here's an example. We're going to solve x minus 7 is less than 2, and 2x plus 1 is less than 9. Now, solving this is very easy. You already know how to do it. So why don't you just hang out for a second and just watch? All right? Here's how you do it. You're going to solve equation 1 first. So I guess I said equation. You're going to solve the first inequality. So I add 7 to both sides. I get x is less than 9. So then I come over to the right. All right, and I'm not going to get too specific with spacing. I know 9 is positive, which means it's to the right of 0. Since this is less than, this is pointing to the left. So I know I'm going to shade to the left. And since it's less than, I use a parenthesis. Recall, I'll come up here real fast. Parentheses are used for less than or greater than. Brackets are used for less than or equal to, or greater than or equal to. All right? So there's the first equation, our first inequality. Now I'll do the second inequality. 2x plus 1 is less than 9. So I subtract 1 to both sides. 2x is less than 8. Divide both sides by 2. That gives me x is less than 4. So I come over to the left-hand side here, or I'm sorry, the right-hand side. Now I'm a little bit more concerned. Okay, I'm a little bit more concerned with the spacing. And the only reason for that is because I want to make sure that the 4 doesn't extend past my 9. So x is less than 4. Once again, it gets another parenthesis. Shade to the left. I'm going to zoom out here just a little bit, okay? So now, the final part of this problem, we're going to write the solution set. Now, this should look familiar. This is called set builder notation. So we write, and this is always going to be the same. You write x is such that x is less than 9 and x is less than 4. And I'm going to graph this. Now, remember, the and means you satisfy both equations. Okay? Any questions there so far? Now, in order for me to satisfy both equations, what I'm going to do is I'm going to take my two solution sets and put them on top of each other. Wherever they overlap is going to be my answer. So the overlap will be the solution. So when I come down here, they only overlap where x is less than 4. See, if I took this up here, which is my x is less than 9, and I kind of just wrote it underneath here lightly, notice that overlap occurs. Boy, that looks really bad. Maybe I need to use a better... Actually, I think... Oh, come on, bro. I think the magenta or whatever this purple is going to be the best. Yeah. That overlap occurs right here. That's where the overlap occurs. So that's going to be my final solution. Okay? So what you're looking for is the overlap. All those values in the shaded region of the last number line will satisfy both equations. It's real simple to check. Pick a number that is inside the shaded region, substitute it in. It has to satisfy both. If it does, you know your shading's correct. What number is in the shaded region that I really like?
0.
Yes. Whoever said 0 is a genius. I always choose 0 if it's available. All right? So here we go. Here's my check. 0 is less than negative, or 0 minus 7 is less than 2. So you ask yourself a question. Is negative 7 less than 2, yes or no?
Yes.
Perfect. So I put a check mark. Next one. 2 times 0 plus 1 is less than 9. 2 times 0 is 0. 0 plus 1 is 1. Question. Is 1 less than 9? Check. So I know my shading's correct. Does that make sense, everybody? All right. Let's look at another example. All right, now this time I'm going to speed up here a little bit. I want us to solve 4 times x is less than or equal to 7, and 3 times x plus 2 is greater than 8. Okay? Write the solution in interval notation. All right, that's what we did above. So, like I said, I'm going to just speed up just a little bit here. 4x is less than or equal to 0. That means x is going to be less than or equal to 0 when I solve. So I do my number line. I put a 0 right in the middle. And I want values of x that are less than or equal to. So I'm going to shade to the left. All right, for the second inequality, 3x plus 2 is greater than 8. I will subtract 2 from both sides. That gives me 3x is greater than 6. Divide both sides by 3 to give me x is greater than 2. So once again, I'll do my number line. 2 is on the right-hand side of 0. And it's going to be greater than. So, parenthesis, shade to the right. Are there any questions so far? All right. Now, when I write my solution set, so x is less than or equal to 0, and x is greater than 2, and I put these two number lines on top of each other. Do they overlap at all? So if they don't overlap, is there a solution? No, very good. No solution. Another way to rewrite that is this symbol right here. This is called, that symbol that I just wrote, that 0 with a line through it, diagonal line by the way, it's called the empty set. It means, think of having a big house with nothing inside of it. It's empty. So it's the empty set. There are no values there. Okay? Are there any questions? So before we go any further, I just want to know, is there anything that we're confused about? I mean, all we're really doing here is I'm giving you two problems at the same time. And I'm saying, okay, solve the first, graph it. Solve the second, graph it. If the word is an and, where do they overlap? Any questions? Are we sure? All right. Let's look at this type of problem now. Okay? So we have these types of problems, okay? And they're called double inequalities. All right? So double inequality is exactly what it sounds like. It has two inequalities inside of the problem itself. So an example would be something like this. Okay? So notice here, we have two inequalities. And if I read this left to right, it's 2 is less than 4 plus x, which is less than 8. Now, we can solve this. Or we can solve and write the solution in interval notation. And you already know how to do this. I mean, you really, really do. Somebody finish this statement for me. Whatever you do to one side of the equation, you do to the other side, okay? Now, this, we're just going to adapt that phrase to our problem. Whatever we do to the middle of the double inequality, we're also going to do to the left and to the right. In other words, we know we want to solve, which means we want this x in the middle to be isolated. In order for me to do that, I need to subtract 4. But if I subtract 4 from the middle, I will subtract 4 from the left and subtract 4 from the right. And I just crunch a number straight down. 2 minus 4, negative 2, less than. I get an x in the middle. And then less than 8 minus 4 is positive 4. And that's it. That's as hard as it got. From here, we're going to write out our number line. I like to do this directly underneath, because I will put negative 2 and 4 and then a 0 right in the middle. See how I just write everything directly underneath? Now, when you have double inequalities, a good way to think about them are the outside numbers, in this case it's negative 2 and 4, are going to capture the x. In other words, the x is going to be anywhere in between negative 2 and 4. The question becomes, are you allowed to include negative 2 in your answer? And the answer to that is no, because it's less than. If that was less than or equal to, then you would include it. But since we can't, we're going to draw a parenthesis at negative 2, and we're going to do the same at positive 4. And we're just going to shade everything in the middle. Kind of looks like a TIE fighter. That's a Star Wars reference for you non-Star Wars fans. Now, if you've done the math correct, you did your shading correct, your interval notation is staring you in the face. It's the parenthesis, negative 2, comma, the 4, end parenthesis. And that's it. So what this is telling me here is x can be any number I want it to be, as long as it's in between negative 2 and 4. And I'm not allowed to include those endpoints. Okay? Are there any questions? Pretty straightforward, everyone? I'm not really hearing too much feedback here. I'm getting nervous. All right. Let's look at, in my opinion, worst case scenario. This is the worst case scenario for me. Okay, let's look at this example here. We're going to solve and write solution in interval notation. All right, now, I'm telling you right now, this is worst case scenario for me. So, let's go ahead, let's solve it. I go right to the middle because it's a double inequality, so I go right to the middle. I will subtract 4 from everything. So subtract 4 from the middle, from the left, and from the right. Now, 2 minus 4 is negative 2. Less than negative x, which is less than 7 minus 4 is 3. Now, I'm not done yet. Because remember, I want x in the middle, not negative x. So I need to divide by the number in front of the variable. Well, in this case, it's going to be negative 1. So I divide everything by negative 1. What happens to my inequality symbols when I divide by a negative number? Very good, they switch. So I get negative 2 divided by negative 1, which is positive 2. The less than switches to a greater than. In the middle, I get positive x. The less than flips to a greater than. And 3 divided by negative 1 is negative 3. This is the worst case scenario. Because if you really look at this and you read it from left to right, how come, or does it make sense to put a positive number before a negative number? I mean, does that make sense at all? I mean, on a number line, you got 0 in the middle. Negatives are to the right. Negatives are to the left, positives are to the right. So this is the worst case scenario here. And it's the worst case because what you're going to have to do is just reverse everything. What I mean by that is this. Don't leave your answer like this. Reverse everything. I'm going to put the -3 first. And remember, this arrow, that inequality symbol on a -3, is pointing to the -3. So I'll make sure it's pointing again. And now I have it in its proper form. Okay? Are there any questions there? So when you divide by a negative number, you got to make sure that you reverse the inequality symbols, and then when you write your answer, you just flip it around. I will go ahead and graph. I'll do it directly underneath. I'll keep it consistent. There's my -3. There's my 2. Put a little 0 in between. And we just shade everything in the middle. So my interval notation, staring me in the face. All right. Any questions? Okay, good. All right. All right, now we're going to transition a little bit. We're going to do the union. Once we do the union, I'm just going to start throwing problems at us, okay? So the union of two sets, or better yet, let's write it like this. The word or denotes the union of two sets. Now, what does that look like in a Venn diagram? So you have set A, you have set B, and the union satisfies the first set or the second set, or both. In other words, the union is everything. We denote that with the letter U, that A union B. In fact, excuse me. In fact, if you've ever been to a wedding, like my wedding, I remember our wedding officiant came up and he said, "Welcome to the union of these two people." That meant Molly's family and my family are coming together. It's the same thing here in math. What we're really concerned with is we are looking for values of x that satisfy either equation. All right? Either means one or the other or both. So one or the other or both. In other words, when you check your answer, all you got to do is just make sure it satisfies one of them. That's why earlier in the class I wrote at least one, because at least one means one or two or both. Does that make sense, everybody? All right, so let's look at an example now. So we're going to solve 5x minus 3 is less than or equal to 10, or x plus 1 is greater than 5. Our method doesn't change whatsoever, okay? We solve the first inequality. So to do that, I will add 3 to both sides. That gives me, excuse me, 5x is less than or equal to 13. Divide both sides by 5 to give me x is less than or equal to 15 over 3, or, sorry, I have it backwards, 13 over 5. Now, if you don't know where to graph that, remember, you can always convert an improper fraction into a mixed fraction. 5 goes into 13, 2 times with 3 left over. So this is x is less than or equal to 2 3/5. Okay? So I will go ahead and graph this. Put my 0 in the middle. 2 3/5 is like over here. It's to the right. I'm not too concerned with where it is specifically. So I'm just going to write 13/5 above it. I want values of x that are less than that. And I include the 13/5. So it's a bracket, and I shade to the left. All right, so there's the first part of the problem. The second part, x plus 1 is greater than 5. So to solve this, I just subtract 1 from both sides. And I get x is greater than 4. Okay? So here I shade again. So I put a 0 right in the middle. I'll label the 13/5 so I know where it is. But I want x is greater than 4. So that's a parenthesis. And I shade to the right. Now, I write out the solution set. Okay? So that's going to be x is such that x is less than or equal to 13/5, or x is greater than 4. I'll label each of my, critical values, I guess. I will shade. Oops, wrong symbol. And here we notice there is no overlap, and that's okay. Our solution will be the shaded regions. So, negative infinity all the way up to 13/5, and I can include it. That's why it gets a bracket. Union 4 to infinity. I cannot include the 4, so I put a parenthesis. Are there any questions with how I did that? Yes, no, maybe so? So the hardest part about this section is just remembering the differences between and or. And has to satisfy both. Or only has to satisfy one. Okay? Any questions? Well, let's check something. Because I know when I was learning this, this always bugged me. What about this region right here, where I just put that little red circle? Give me a number inside that region. Now remember, this is really 2 3/5. So what's a number in between 2 3/5 and 4? Give me a number in between 2 and 3. Or, I'm sorry, I gave you the answer. Give me a number in between 2 and 4. 3, all right? So watch this. I'm telling you the solution is going to be in either of those two bounded regions, okay? Negative infinity to 13/5 or 4 to infinity. Watch what happens if you actually choose a number that's not inside those two, like the number 3. 5 times 3 minus 3, less than or equal to 10. So 5 times 3 is 15. 15 minus 3 is 12. Is 12 less than or equal to 10? No. What about the other one? 3 plus 1 is greater than 5. 3 plus 1 is 4. Is 4 greater than 5? No. So, make sure that you understand what's really happening here. With the or, it doesn't matter what region you pull a number from. It just has to satisfy at least one equation. Okay? If you pick a number that is not in the solution set, it's going to fail both of them. And you need it to work in at least one. All right, let's look at another example here. Another or. This one's fun, to be honest with you. Solve -3 times x minus 2 is greater than -8, or 5 is greater than 0. And we're going to write the solution set in interval notation. So that's never going to change. So let's solve the first one. So to solve this, I add 2 to both sides. That gives me -3x is greater than -6. Now you got to be careful. I divide both sides by a -3, which means my inequality symbol switches. So I get x is less than 2. All right, so make sure you're aware of that switch. Now the next inequality, 5x. Yeah, 5x is greater than 0. Okay, so that's going to be divide both sides by 5. X is greater than 0, so I'll go ahead and graph that. And that's shaded to the right. And remember, the last step is always going to be the same. You're going to have the squiggly braces with x is such that. Then you just write whatever your solution was. X is less than 2, or x is greater than 0. And here's what's interesting about this one. When I put these two graphs on top of each other, they overlap everywhere. I mean, if you think about it, here's the 2, it goes this way. Here's the 0, goes this way. And the entire line is shaded, which means my solution set is -infinity to +infinity. Okay? Are there any questions there? All right, now, there's one more example I want to do because I want to make sure that we are completely aware of the differences between these two problems. Okay? All right, so here's the difference between these two problems. All right? Because you're going to see something here. With the first inequality, I solve it by dividing both sides by 3. And that gives me x is less than or equal to 5. So I graph it. All right. The second inequality, I solve that one. Once again, I just divide both sides by 3. They give me x is greater than or equal to 3. So I graph this. All right, so it gets a bracket, and I shade to the right. Now, for the final step, I write my squiggly braces. I write whatever I got. X is less than or equal to 5, and x is greater than or equal to 3. So here is the difference between this problem In fact, everybody, just do me a favor. Just watch the screen. Just watch the screen. Because I got to zoom out. Here's the difference between this right here and what I'm about to do. If I were to overlap these two, it would look like this. All right? This is exactly what it would look like if I were to overlap. But here's the difference. Since the previous problem is an or statement, the overlap is everywhere. Okay? Since this is an and statement, the only solution, even though they overlap, is right there. That's it. Because remember, when it's an and statement, you have to satisfy both equations at the same time. The or statement, at least one. Doesn't matter. But that and statement is very specific. So when I go ahead and write my final solution, and I'm going to do this in red so you know it's different. It's only right there in the middle. And my interval notation is bracket 3, comma, 5 bracket. That's it. So do we see the difference here? That is the number one mistake students make, is they think, oh, it overlaps, so it's just everything. No. It depends on what the compound statement is. Is it an and statement or is it an or statement? Does that make sense, everyone? All right, that's the biggie. So I'm going to give 3 problems to do. We do these three problems. It'll probably take us up to the end of the class, and then we'll be done for today. Good? All right. So here's what I'd like you to do. Solve the following. Right. Stupid cat. Oh. You know, Galileo, you're so good at jumping, yet you don't jump properly. Now you woke up the dog. Did you guys see like the big light just smashed down in my room? I have a piece of drywall so I can lock the dog inside the room with me. Galileo goes to jump over it, and he always he's so good at jumping, yet he doesn't jump over this thing right. Anyways, write your answer right in interval notation. All right, so here we go. So here's your first example. Do x plus 1 is greater than or equal to 7, and 3x minus 1 is greater than or equal to 5. All right. Do that one. Do the double inequality. Oh, I'm gonna throw a tough one at you here. One is less than or equal to 2. 2 over 3x plus 3, which is less than 4. And then the last problem I want you to do, obviously, is going to be an or statement. So we're going to do 3 times the quantity x minus 1, which is less than 12, or 4x is greater than negative 12. So I'm going to give you like 5-10 minutes to do these. I got to go fix my light. Anybody need any help? Okay. Okay, are we ready? Did I give you enough time? I don't know. All right, we ready to go over this? All right, let's try it out. We'll do the first one. So with this first one, we just solve each inequality. And remember, it's an and statement. So I'm looking for the intersection. So x plus 1 greater than or equal to 7. Subtract 1 from both sides. I get x is greater than or equal to 6. So let's go ahead and graph this. See, greater than or equal to, so it's a bracket. And I want numbers that are larger than 6. Perfect. Now, the second inequality. 3x minus 1, excuse me, is greater than or equal to negative, or greater than or equal to 5. So I add 1 to both sides. So I get 3x is greater than or equal to 6. And then divide both sides by 2. Sorry, that's the answer. Divide both sides by 3 to give me x is greater than or equal to 2. All right. So from here, hopefully you could see that there will be an overlap, okay? And remember, I need the overlap that satisfies both equations, and that's going to occur zoom out here so we can see everything. So that'll occur when x is greater than or equal to 6 and x is greater than or equal to 2. So there's my 0, there's my 2, there's my 6, and then overlap occurs right there where I have those circles drawn. So, oops, the first solution is including 6 and then going to infinity. Good? Any questions? All right, we'll do the next one. So this second one, I made it just a little bit difficult because I threw a fraction in there. But that shouldn't mean anything to us. We see a fraction, we know how to deal with it. Multiply everything by an LCD to eliminate the fraction. So watch what I do. 3 times 1 is less than or equal to? What just happened? Did all that just disappear? Now it reappeared. Come on. What are you doing to me? What are you doing to me? I think my computer's wigging out. I think it's going crazy. All I need is this. Yeah, I think it's going bananas on me. All right, let's do this again. I'm going to multiply everything by 3. 3 times 1 is less than or equal to 3 times 2 over 3x plus 3 times 3 is less than 3 times 4. Remember, nothing changes. Just multiply everything by 3. Now, I get 3 is less than or equal to. The 3's reduce. So I get 2x plus 9 less than 12. From here, I subtract 9 from everything. On the far left, 3 minus 9 is negative 6. In the middle, you have 2x. On the far right, 12 minus 9 is 3. Last move, I divide everything by 2. To give me negative 3 is less than or equal to x, which is less than 3 over 2. It's not a nice number, but that's okay. From here, directly underneath, I'll do my line. Negative 3, 3 over 2. And I just make sure that I use the appropriate symbol, whether it's a bracket or parenthesis. The negative 3 is less than or equal to, so it gets a bracket. The 3 over 2 is less than 3 over 2, so it gets a parenthesis. And I shade in between. And then I will just write the interval notation for it. Okay? Any questions there? I'm going to scrub just a little bit for the last problem. Okay. So our last problem, it's an or statement. So be careful, it's an or. So I copied on the first inequality. I have to distribute the 3. Then I will add 3 to both sides. 3x is less than 15. Divide both sides by 3 to give me x is less than 5. So there's my number line for that. Second example, 4x is greater than negative 12. Divide both sides by 4. You get x has to be greater than negative 3. Negative 3 is to the left of 0. And x is going to be greater than that. And since this is an or statement, I know we're going to have that immediate overlap. Oh, sorry. X is such that x is less than 5 or x is greater than negative 3. The shading is everything. It's the entire line. And that's just going to be negative infinity to infinity. Or all real numbers. Okay? All right. Woo, what a day.